All right, let's talk about this little homework assignment here that goes along with graphing linear inequalities. I'm not going to do the whole thing, but I'm going to run you through how you do some of it, okay? So I think you should be able to find intercepts. That's your y. You got to figure out the coordinate. That's your x. I think you can do that. Now, if a point is a solution, it's in the shaded area. This blue part over here is shaded. This part's unshaded. So if this point is on this side, then the answer is yes. And if the point is on this side, the answer would be no. So negative 2, oh, it's actually on the dot, on the line, so that is kind of tricky. You see, it's a solid line. Remember, solid lines are or equal to. So this would absolutely be a solution. However, if it was a dotted line, the answer would be no. All right? So what this is asking you to do is figure out which of these points is either on the line or in the shaded area. Now again, if this was a dotted line, if it was on the dotted line, no solution, no deal. So anyway, 0, 0 is right there, so it would be a yes. Do you see? Negative 5, 6, shade is unshaded, no. That's what you got to figure out. Which of these points are solutions, and if they are, you circle it. All right. Now here, this is designed to help you get familiar with how you graph, right? That's it. So we have some that are in slope-intercept form. We have some that are in standard form. Let's see, just looking through here, none are super tricky, so how about we do two of them? How about we do this one, and we'll do this one, right? The rest are all the same as one of those two. So first thing first, when you're graphing in standard form, we'll do this one first. Remember, you're going to want to find those intercepts, right? You're going to find the intercepts, then you're going to figure out is the line solid or dotted, and then you're going to figure out which way you shade, right? So let's do that right here. So this one, solid or dotted, solid. Lines underneath, solid for sure. This one is dotted. No line underneath, it's strict inequality. Okay, so let's find 2 points that are on this line right here. This is what it's asking us to do. So we're going to find the intercepts for this one. So if I put, right, C over A, that's our x-intercept. So that's 8 over 2, that's 4. And if we do C over B, that's our y-intercept. That would be 8 over 4, which is 2. Right, so 4, 1, 2, 3, 4, and 1, 2. Now let's go ahead and connect those dots because I know it's a solid line. So let's do that right here, just like that. All right. So now, test points. What we're being asked to do is plug these things into the equation and see if they are solutions or not. If it is a solution, we circle yes. If it's not, we circle no. So I'm going to do that as scratch work over here. So 0, 4. So 2 times 0 plus 4 times 4, that's 16. Is 16 greater than or equal to 8? Yes. So 0, 4 is up here. So that means I'm going to be shading above for sure. But let's go ahead and check this next one. So let's do negative 2 and negative 1. So I've got 2 times negative 2 plus 4 times negative 1. I don't really have room to write. Greater than or equal to 8, okay? So that's negative 4 minus 4, that's negative 8. Is that greater than or equal to 8? No. Right? So we're good to go. So negative 2, negative 1's here, that's a no. The other one, 0, 4, is a yes, and it's above. So I shade it above just like that. Boom, done. All right. We're going to do one that's in slope-intercept form. This one's a little easier. To graph anyway, you don't have as much algebra to do, but we do need 2 points anyway. But we're going to get the second point by counting the slope. So let's get started. I know 0, 4 is the y-intercept. So 0, 4, 1, 2, 3, 4, y-intercept, right? We already said y was dotted. It's a strict inequality. Now our slope is negative 5 over 2. So 1, 2, 3, 4, 5, 1, 2. Right? So down 5, right 2, or up 5, left 2. So you can go up and left, that would be negative, or you can go down and right, that's also negative, right? So from left to right, if the line's going down, we're good to go. Now, we have our 2 points. This looks like it's 2, negative 1. All right. And we have a dotted line this time. So you get 2 points, figure out if it's solid or dotted, and then you figure out, do you shade it above or do you shade it below? So we have a test point 0, 0, which is right there. If I plug 0, 0 in, I get 0 is less than 5 over 5 halves times 0 is just 0, 4. So is 0, 0 less than 4? Sorry, is 0 less than 4? Well, absolutely it is. So that is a yes, for sure. Now let's do 3, 5. So is 5, let's see here, less than negative 5 over 2 times 3 plus 4. All right, so let's see here. This is going to be fine. I'm going to do a little scratch work right here. So this is going to be negative 15 over 2 plus 4. That's negative 7. Sorry, negative 7.5 plus 4. Is that more than 5? Like, I don't even think you need to figure out this number. Is like 4 is less than 5, and if I'm taking a number away from 4, then there's no way that's true. That's obviously false. So let me explain that again. Look, we don't need to know what this number really is. We just need to know, is it bigger than 5? Turns out it's not, because if we're starting with 4 is less than 5, so we'd have to add more than 1 in order for it to be more than 5. We're taking away a number, so it's going to be less than 5. So I don't even need to know what the number is. The answer is no. Now, if I did want to know the number, it would be, what, negative 2.5, right? So, no, 3.5. Yeah, negative 3.5. And that is, of course, right, not more than 5. That's false. That's not true. So anyway, 3, 5, 3 5's over here. 3 5's over here. That was a no, and the other one was a yes. So the answers the solutions are the values that make it true, and they're shaded and they are below. So that's how you're going to do all of those. Anyway, I hope this is helpful.